Apache Kafka. If you work with data in any capacity, you're either already using it or you will be soon. Why? Well, because it's become the universal foundation for applications and data pipelines everywhere. And yes, I know there are a lot of intro to Kafka videos out there. Some of them are even mine. But I really think now it's time for a fresh look at where Kafka is and where it's headed. Just in case you're new here, I am going to start with the basics. But then I want to show you how this simple piece of infrastructure is upending application and data architectures in ways I never saw coming, and how a whole platform is emerging on top of it. And of course, we also have to talk about how Kafka and AI are related. Now, backing up a step, maybe the most intuitive way to model the world in software is to think about things. Things like a user who signs up for the website, a smart car, a connected car, something like that. It's very straightforward to model those things in a database. Each record in the database, usually a row, corresponds to a thing out in the world, maybe that connected car. And when the thing changes out in the world, you update the row in the database. So this kind of thing-oriented thinking is very traditional and really intuitive. Kafka invites us to take a different approach. Rather than thinking about the things, Kafka encourages us to think about events. Not things, but things that happen. And so something happens out in the world. Let's stick with the connected car, right? This thing out there. Maybe I start it up. Well, that's an event. I put it in reverse. That's an event. I hit the accelerator and do certain things. These are all events that are happening with that car out there being produced into this log of events. They get written in there. They're immutable. Events never change after the fact. Kafka calls this log a topic. Now, in the old days, in the thing-centric view of the world, we had a database that was kind of the center of the universe, and we came to create one big application to sit in front of that database. And we called this, at least we eventually came to call this, the monolith. Kind of make it sound scary, right? And that was fine. Monolith served a purpose. There's a user out here and, using a web browser on a laptop or a mobile device or whatever it is. And that user, fills out a form, clicks on a thing, the monolith does some work, asks the database a question, the database gives it an answer, and then the user sees that information. That worked until it didn't. Eventually, the monolith became too big to think about. Developers had a hard time maintaining this big piece of software, too big to easily test and deploy. And kind of a different idea, a different way of architecting systems emerged that sort of coincided with the emergence of Kafka. And instead of this big giant program, we decided, we're going to write, a bunch of small programs that we call microservices or simply services. And each one of them has a little piece of work of the system to do. It performs a simple task. Some of that might be related to the user interface. Some of it might be just talking to other services in the system. And initially, when we first started playing around with microservices, it was a rough go. It was kind of hard to get this sort of architecture to work until we realized that event logs, like you could find in Apache Kafka, were a great way to connect these services. A service would do its work and produce the result to a topic, which could then be consumed by some other service. It could pick it up, and these could all be orchestrated or choreographed all together to accomplish what the monolith used to do. And Kafka was a key enabling technology of this software architecture revolution here that happened from going from monolith to microservices. What about analytics? Well, let's go over here and put a good old data lake here. You might call it the lake house or cloud data warehouse, whatever. Now, traditionally, this thing has been filled up by batch processes. You've got, this database, and of course there are other of these databases around. And in the bad old days, we'd have an overnight batch process that would take the data out of all those databases in the enterprise, dump it into the data lake. These days, increasingly, what you've got is the data lake being fed by Kafka. So some of this data in these topics may be extracted in real time from databases through a process called change data capture. And we've got our microservices estate over here, this new architecture where you've got a bunch of small programs talking through Kafka topics. Well, maybe the data of the business is just over here in these logs, in these topics, and these can also be things that end up feeding the data lake. So you have a revolution in application architecture, you've got a revolution in analytics, a data architecture as well, all being driven by Kafka. So Kafka is here, and let's just call the basics here. This is streaming. So we have a way to stream data, to move data around in real time. What's going to happen next, though, is we're going to realize there are these other legacy systems. I've drawn some databases. Maybe there's some SaaS application that's important to the business. Mainframe, could be anything, right? There are all these other systems that we need to get data from, and then there are places we need to move data to. Not just the data lake, but maybe other places in the cloud where we want all this process data to go to. Well, you don't want to do all that integration work yourself, right? There are probably in the world a few dozen, 100 or so maybe, different kinds of integrations that we really need. And for that, there is a system called Kafka Connect. What that is a pluggable framework for doing this integration. Rather than you sitting down and writing the code to read messages out of a topic and write them somewhere, or pull them out of a database and write them into a topic, that's repetitive. Now there's a pluggable framework. You go get the connector, install it into the running Kafka Connect server, and it will do that integration for you. What's going to happen, though, with the data in the topics? Like suppose, I've done this, I've pulled data in from my SaaS application here. Is it exactly right? Is it perfectly ready to go? Exactly what I need for the rest of my system? There's nothing I need to filter. There's nothing I need to enrich from some other source. I mean, what would be the odds, right? So we're going to have to do some kind of processing of this data also. Stream, connect, and process. Now, there are a number of ways to do this. I can roll my own. I can just, use the consumer API, it's called, to do all that stream processing, the joining, the filtering, the grouping, the aggregating. That's really a tall order. I could use Kafka Streams, which is a Java API that comes with Apache Kafka. Increasingly, folks have been using another Apache project called Apache Flink. It's a common stream processing solution at scale to be able to do the work on the events in real time. So we're able to stream, we've got topics, we've got an integration framework, which is Connect, and we've got processing in Flink. And what about, I've got these little squiggles in here. That's like JSON data or Avro or protobuf or something like that. Those are schemas, those are objects, those are things that are going to change. This application, it's going to get versioned. That's the whole point. It's a microservice. And the format of those messages is going to change. What about all my collaborators in the system? We're going to have some way of managing schema at scale. We need a schema registry, or really, I know it's a little bit of a dirty word, but we need data governance. That's really, schema management's the foundation of data governance, because schema is going to evolve because the world changes. And so that's a very important layer here in this whole platform. These are all things, if they didn't exist, you'd have to create them. Happily, you don't. They're already there as a part of Kafka as a platform. What about AI? I mentioned that too. We kind of need to get that on the board, because these microservices might not just be programs that you write, but they might call out to, a large language model out there on the internet, right, to do their work. As this user puts in, free text queries or requests of the system, this service it might become an AI agent that calls out to a large language model. That large language model is going to need to be enhanced or augmented with all of the data from the enterprise, all the data in all these databases, Google Docs, wikis, whatever that is. That stuff that this foundation model, Claude, ChatGPT, whatever, doesn't know about, that all needs to be augmented. And to do that, that requires real-time streaming data to be a part of life. So if we're going to have an AI solution, we need to have this data streaming platform in place. So what is Kafka? Well, in the simplest terms, a distributed log. More than that, it's the foundation of a revolution in application architecture, in data architecture, and the foundation of any practical use of AI in the enterprise. And it's the basis of this platform, this streaming platform that's emerged, not just to stream data, but you've got integration, you've got stream processing, you've got data governance. Those are all things that are going to need to be a part of your life. How do you run this? Well, these are all available as open source components. You could certainly do that on your own. Also, I work for a company called Confluent. We've got a bunch of people who have spent a bunch of time and effort to make this easy to do in the cloud. We've got a fully managed data streaming platform solution, managed Kafka, Kafka Connect, Flink, and data governance. There's a link in the description below to a free trial that you can use to get started right away. And leave us a comment. Let me know what you're building. I always love to hear those stories. Thanks.